What if I told you some bulldozers built over 40 years ago could still embarrass today's high-tech machines? No touchscreens, no sensors, just raw steel, massive engines and engineering that refused to quit. The 1980s gave us bulldozers that worked longer, pushed harder, and survived conditions that would cripple modern models loaded with electronics. These weren't designed for comfort or software updates. They were built to move earth all day, every day, no excuses. Today we're counting down 10 bulldozers from the 1980s that could outwork modern models, and by the end you'll understand why old-school iron still earns respect on job sites worldwide. Number 1. Caterpillar D8K. The Caterpillar D8K is widely regarded as one of the toughest bulldozers ever built, and its reputation was forged in the late 1970s and early 1980s on some of the harshest job sites in the world. Designed before emissions regulations and electronic controls complicated equipment design, the D8K relied on raw mechanical strength and simplicity. At its heart was the legendary Cat 3408 diesel engine, a massive V8 that delivered enormous torque at low RPM. This engine was deliberately understressed, meaning it rarely operated near its mechanical limits, which is why many D8Ks accumulated 30,000 hours before requiring major overhauls. The D8K's structure was built with thick steel plate and massive castings, especially in the main frame and equalizer bar. These components absorbed punishment that would twist or crack lighter modern frames. The undercarriage was equally impressive, designed for rebuilding rather than replacement. Track frames, rollers, and sprockets could be serviced repeatedly, allowing the machine to stay productive for decades. What truly set the D8K apart was its ability to push continuously without overheating or losing efficiency. Operators trusted it on large earth-moving projects, mining operations, and dam construction, where failure was not an option. Even by modern standards, a well-maintained D8K can outpush newer machines in sustained heavy material because it delivers torque consistently rather than in bursts. That steady, unstoppable nature is why the D8K remains a benchmark for bulldozer durability. Number 2. Komatsu D155A-2. The Komatsu D155A-2 became one of the most respected heavy bulldozers of the 1980s, especially among contractors who valued brute force and mechanical reliability. Introduced during Komatsu's aggressive expansion into global markets, the D155A-2 was built to compete directly with Caterpillar's large dozers, and in many cases, it succeeded. Powered by a massive Komatsu diesel engine, the machine delivered exceptional torque and pushing power while maintaining excellent fuel efficiency for its size. One of the D155A-2's greatest strengths was its drivetrain. Komatsu engineered the transmission and final drives to handle extreme loads without premature wear. These components were oversized and conservatively rated, allowing them to survive long duty cycles in mining, logging, and large-scale earth-moving operations. The blade linkage and C-frame were heavily reinforced, preventing flex and fatigue cracking even after years of hard pushing. Hydraulics on the D155A-2 were simple, robust, and predictable. There were no electronic controls to fail, and pressure systems were designed to tolerate contamination better than modern systems. This made the machine especially valuable in remote locations where maintenance resources were limited. Operators often remarked that the D155A-2 felt unstoppable, capable of maintaining push speed where newer machines would slow down or require more frequent cooling breaks. Its ability to work long hours under heavy load is why many D155A-2s are still operating today, often rebuilt but far from obsolete. Number 3. Caterpillar D6H Series 2. The Caterpillar D6H Series 2 is often considered the perfect balance between size, power, and durability. Introduced in the mid-1980s, it became one of the most popular bulldozers ever built, and for good reason. Powered by the Cat 336 engine, the D6H delivered excellent torque and fuel efficiency while remaining exceptionally reliable. The 3306 was a proven engine design that tolerated abuse, poor fuel quality, and long service intervals without complaint. Structurally, the D6H was engineered to handle continuous work. The main frame, blade arms, and ripper mounts were heavily reinforced, reducing stress concentrations that lead to cracking. The undercarriage was designed with longevity in mind, using thick rails and rebuildable components that allowed owners to extend service life dramatically. The D6H excelled in versatility. It could handle finish grading, heavy pushing, and ripping with equal confidence. This adaptability meant contractors could rely on a single machine for multiple tasks, reducing fleet complexity. Operators appreciated the smooth power delivery and excellent visibility, which translated into precise control and reduced fatigue. Even today, many contractors prefer a well-maintained D6H over newer models because it works longer hours with fewer interruptions. Its combination of simplicity, strength, and reliability allows it to outwork modern dozers that are more technologically advanced but far more sensitive to downtime. Number 4. Komatsu D65A-6. The Komatsu D65A-6 became one of the most widely used medium-sized bulldozers of the 1980s, earning a reputation for reliability that still holds strong today. Designed for construction, road building, and agricultural land clearing, the D65A-6 was powered by a rugged Komatsu diesel engine that delivered strong torque at low RPM, reducing wear and extending engine life. One of the defining features of the D65A-6 was its balance. Komatsu engineered the machine to distribute weight evenly, maximizing traction while minimizing stress on the undercarriage. This allowed it to push efficiently without excessive track wear, a major advantage over lighter modern machines that rely on electronics rather than mass for traction. The drivetrain was simple and durable, designed to handle repeated shock loads without failure. Final drives were oversized, and the transmission was built for longevity rather than speed. Hydraulics were equally robust, using proven designs that tolerated contamination and heat. The D65A-6 became a favorite among contractors who needed a dependable dozer that could work daily without drama. Its ability to run long shifts with minimal downtime allowed it to outperform newer machines that required frequent sensor resets or electronic diagnostics. That consistency is what made the D65A-6 a legend. Number 5. Allis-Chalmers HD21. The Allis-Chalmers HD21 was already a legend by the time the 1980s arrived, but it continued to dominate job sites throughout the decade. Built like an industrial brute, the HD21 featured massive steel components, a heavy frame, and a drivetrain designed to absorb punishment without complaint. Powered by a large displacement diesel engine, the HD21 delivered relentless pushing power that modern machines often struggle to match. The HD21's structure was its defining feature. Thick steel plates, oversized pins, and massive blade arms allowed it to push continuously in rock, clay, and overburden without frame distortion. The undercarriage was extremely heavy and designed for repeated rebuilding, which is why many HD21s remained in service long after Allis-Chalmers exited the construction equipment market. Hydraulics were simple and mechanical, allowing easy repairs and predictable operation. There were no computers to fail, no sensors to shut the machine down unexpectedly. When something went wrong, it was usually mechanical and repairable. The HD21 earned its reputation through decades of real-world work. Even today, restored HD21s are still pushing dirt on farms and private projects, proving that raw strength and simplicity can outlast entire generations of technology. Number 6. Caterpillar D9G. The Caterpillar D9G is one of the most iconic heavy bulldozers ever built, and by the time the 1980s arrived, it had already earned a near-mythical reputation for endurance and brute strength. Designed for mining, quarrying, and large-scale earth-moving, the D9G was powered by the massive Caterpillar D353 V8 diesel engine. This engine was not designed for efficiency or emissions compliance. It was built purely for torque and durability. Operating at relatively low RPM for its size, the D353 could run under heavy load for hours without overheating, making it ideal for continuous ripping and pushing operations where modern machines often struggle. Structurally, the D9G was massively overbuilt. The main frame used thick steel castings and plates that resisted twisting and fatigue even when pushing near the machine's limits. The blade arms and C-frame were designed to transfer enormous forces directly into the frame without flexing, ensuring consistent push power and long structural life. The undercarriage was equally formidable, with heavy track frames, oversized rollers, and rebuildable components that allowed the machine to remain productive for decades rather than years. What truly allowed the D9G to outwork many modern dozers was its simplicity. There were no electronic control units, sensors, or emission systems waiting to shut the machine down unexpectedly. When maintenance was needed, it was mechanical and predictable. Operators trusted the D9G on jobs where failure was not an option, and many of these machines remain in service today, rebuilt but still doing exactly what they were designed to do: push relentlessly. Number 7. Komatsu D85A-21. The Komatsu D85A-21 emerged in the 1980s as one of the most dependable heavy-duty bulldozers in Komatsu's lineup, designed to bridge the gap between mid-size construction work and heavier earth-moving applications. At its core was a robust Komatsu diesel engine that delivered high torque at low RPM, reducing internal stress and significantly extending engine life. This power delivery style made the D85A-21 especially effective in continuous pushing and ripping operations where steady force matters more than top speed. Komatsu engineered the D85A-21 with an emphasis on drivetrain durability. The transmission and final drives were oversized for the machine's class, allowing them to absorb shock loads without premature failure. This was especially important in rocky terrain and land clearing projects where sudden resistance can destroy weaker drivetrains. The blade system was heavily reinforced, ensuring that the dozer could push large volumes of material without bending or fatigue cracking. The undercarriage of the D85A-21 was designed for long service life, with thick track frames and rebuildable rollers and idlers. Proper weight distribution provided excellent traction, reducing slippage and wear. Hydraulics was simple and mechanical, making the machine easy to maintain and repair even in remote locations. Operators valued the D85A-21 for its stability and predictable handling. It didn't rely on electronics to manage traction or power. It relied on mass, balance, and mechanical strength. This approach allowed it to work longer hours with fewer interruptions than many modern dozers, earning its place as one of the most hard-working bulldozers of the 19th. Number 8. Fiat-Allis FD30. The Fiat-Allis FD30 was built during a period when Fiat-Allis focused heavily on producing machines capable of surviving extreme working conditions around the world. Introduced in the late 1970s and widely used throughout the 1980s, the FD30 was designed as a true heavy pusher, capable of moving massive volumes of earth without complaint. Powered by a large displacement diesel engine, the FD30 delivered consistent torque rather than high-speed performance, a characteristic that greatly extended engine and drivetrain life. Structurally, the FD30 was massively reinforced. The mainframe, blade arms, and ripper mounts were constructed using thick steel plate and heavy castings that resisted deformation under load. This allowed the machine to push continuously in hard soils, clay, and rock without structural fatigue. The undercarriage was equally robust, designed for repeated rebuilds rather than replacement, which kept machines working for decades. Hydraulics on the FD30 were straightforward and reliable, relying on proven designs that tolerated contamination and heat. This made the dozer particularly valuable in remote regions where maintenance conditions were less than ideal. Operators appreciated the machine's traction and stability, which allowed it to maintain push power where lighter modern machines would lose grip. The FD30 earned a reputation as a workhorse that could outlast trends and technology. Many FD30s continued operating long after Fiat-Allis exited the bulldozer market, a testament to the machine's raw durability and practical engineering. Number 9. John Deere 850C. The John Deere 850C represented a turning point for John Deere in the heavy bulldozer market during the 1980s. Designed to compete directly with established heavyweights, the 850C was built with a focus on strength, reliability, and long-term productivity. Powered by a robust John Deere diesel engine, the machine delivered strong torque and dependable performance under continuous load, making it well-suited for large earth-moving and land-clearing operations. The 85C's frame was heavily reinforced, allowing it to withstand the stresses of heavy pushing without cracking or twisting. Deere engineers paid close attention to weight distribution, ensuring excellent traction and efficient power transfer to the ground. The undercarriage featured thick components designed for rebuildability, extending service life and reducing ownership costs. Hydraulics were mechanical and straightforward, providing predictable response and easy maintenance. Unlike modern machines burdened with electronic controls, the 85C could be diagnosed and repaired using basic mechanical knowledge. This simplicity allowed it to remain productive in remote locations where downtime was costly. Operators appreciated the 850C's stability and control, which allowed them to work long shifts with minimal fatigue. Even today, many contractors prefer a well-maintained 850C over newer models because it works longer hours with fewer interruptions. Its ability to outwork modern machines lies in its mechanical honesty and overbuilt design. Number 10. International Harvester TD25C. The International Harvester TD25C stands as one of the largest and most powerful bulldozers ever produced by IH, and it remained a dominant force throughout the 1980s. Built for extreme earth-moving, mining, and land-clearing applications, the TD25C was powered by a massive diesel engine that delivered extraordinary torque. This engine was designed to operate continuously under heavy load, making it ideal for demanding projects where downtime was unacceptable. The TD25C's structure was enormous. Thick steel frames, oversized blade arms, and heavy-duty ripper systems allowed the machine to push material that smaller dozers simply couldn't handle. The undercarriage was built for longevity, with components designed to be rebuilt multiple times rather than replaced outright. Hydraulics was simple and durable, allowing field repairs without specialized equipment. The machine's mechanical simplicity meant fewer unexpected failures and easier troubleshooting. Operators trusted the TD25C because it delivered consistent performance day after day. Even after International Harvester exited the construction equipment market, the TD25C continued working. Many machines were rebuilt and kept in service by owners who valued their unmatched strength. The TD25C's refusal to be retired proves that sheer durability can outlast entire brands and generations of technology. So next time someone says newer is always better, remember these unstoppable 1980s bulldozers. Built thick, simple, and brutally reliable, they proved real power doesn't need a computer chip. If you respect old-school engineering, hit like, subscribe for more legendary machines, and comment which classic dozer you'd trust on your job site today.